Hello everyone, and welcome back to the series of videos on big data and Hadoop. So far we have talked about big data, why a RDBMS cannot be used as a solution for all big data problems, and we also talked about the possible use of NoSQL databases systems to solve big data problems. And finally, we also explained what is Hadoop and its architecture. In today's video, we are going to go back in time a little bit and talk about the history of Hadoop and what the future holds for Hadoop, and also why is it important for data scientists and analysts to know Hadoop. Almost everywhere you go online now, Hadoop is there in some capacity. Facebook, eBay, Yelp, Twitter, Salesforce.com, you name a popular website or service, and the chances are it's using Hadoop to analyze the mountains of data it's generating about user behavior and even its own operations. Everyone involved with the information technology at least knows what Hadoop is. Hadoop even serves as the foundation for new school databases, as well as bigger, badder versions of relational databases that have been around for decades. But it wasn't always this way, and today's users are a long way off from the original vision of what Hadoop could be. The seeds of Hadoop were actually first planted in 2002 with the intention of building a better open source search engine. It was started by duck cutting and University of Washington graduate student Mike Caffarella. They called their initiative Nutch, which in turn was a sub-project of Apache Lucene. Duck cutting founded all three projects: Lucene, Nutch, and Hadoop. And each project was a logical progression of the previous one. Apache Lucene is a full-featured text indexing and searching library. Given a text collection, a developer can easily add search capability to the documents using Lucene engine. While Nutch was the most ambitious extension of Lucene, it tries to build a complete open source web search engine using Lucene as its core component. Duck cutting envisioned Nutch to be an open, democratic alternative to the proprietary technologies in commercial offerings such as Google. The projects Lucene and Nutch, though, differed in one aspect: scale. Whereas Lucene was targeted at indexing millions of documents, Nutch should be able to handle billions of web pages without becoming exorbitantly expensive to operate. As you will see later, Apache Hadoop's goal was to be able to scale the entire web. It was around this time, around October 2003, that Google published a paper describing the Google file system. Subsequently, in 2004, Google also released another white paper on their MapReduce framework. Google claimed to use these two technologies for scaling its own search system. We all know the power of Google search engine, and so did duck cutting. So he immediately saw the applicability of these technologies to Nutch, which, as you know, was planned to be an open source search engine. Doug and his team implemented the new framework based on that of Google's and ported Nutch to it. This immediately boosted Nutch's scalability. It started to handle several 100 million web pages and could run on clusters of dozens of nodes. Doug realized that a dedicated project to flesh out the new technologies was required to get to web scale. That is when, folks, Hadoop was born. Yahoo hired Doug in January 2006 to work with a dedicated team on improving Hadoop as an open source project. 2 years later, Hadoop achieved the status of an Apache top-level project. Before we move on, you might be wondering about the name Hadoop and where it came from. Founder of Hadoop, duck cutting, wanted a name that was not already trademarked and was easy to use. One of his sons had a toy which was a yellow stuffed elephant, and he had named it Hadoop. Inspired by this, Doug named his project Hadoop. In fact, Doug seems to have been inspired by his family while naming his projects. Lucene is his wife's middle name, whereas his son, when a toddler, used Nutch as the all-purpose word for meal. In February 2008, Yahoo announced that its production system for indexing the web was Hadoop, and it was running on a 10,000 plus node Linux cluster. Hadoop now had truly hit web scale and was now waiting to be adopted by companies. But Hadoop was open source. So was it enterprise ready? In order to successfully sell Hadoop to the enterprise, the platform must meet certain levels of, for lack of a better term, enterprise readiness. For all its promise, Hadoop had a few inherent weaknesses that at that time made it a less than ideal platform for supporting mission critical applications and workloads. These must be overcome for Hadoop to emerge as a truly enterprise grade platform. While Hadoop has come a very long way in a relatively short period of time from an enterprise readiness perspective, clearly it was still an emerging technology while at the same time taking giant strides towards stability. Also, there simply weren't many skillful Hadoop practitioners around to help companies architect, design, set up, and manage Hadoop clusters. While Hadoop pioneers, web giants like Yahoo, Google, Facebook, and LinkedIn can devote armies of administrators and engineers to keep Hadoop clusters up and running efficiently, most enterprises cannot. There simply weren't enough skilled Hadoop practitioners to go around and take Hadoop to enterprises. So what now? What actually happened was that Hadoop went commercial. For reasons above, entrepreneurs sensed an opportunity to make big bucks in the potentially $50 billion big data industry. Companies started to package Hadoop for easy setup and maintenance of the cluster. Cloudera, a startup, started the trend by emerging as the first commercial Hadoop distribution vendor in 2009, and a few of them followed suit. Currently, there are 6 major Hadoop distributions: Cloudera, Hortonworks, MapR, IBM, EMC Greenplum, and Intel. Microsoft was also not the one to be left behind. Although Apache Hadoop runs primarily on Linux, Hortonworks and Microsoft have partnered to bring the benefits of Apache Hadoop to Windows as well. The core of most of these vendors, though, is based on the open source Apache Hadoop and its related subprojects, with the real differentiation being the installation, administration management add-on tools, and the support structure. All the vendors have a basic free version with some management tools also included for free, but some of them also have an enterprise version which will have more advanced features and will be charged. It is not only that we have many Hadoop distributions today. Hadoop also inspired a lot of startups lately. There have been more than 50 known startups that are coming up with Hadoop-based products and many more that we might not be aware of. All these startups focus on big data analytics. While some of them specialize on visualization or reporting on big data, some of them focus on processes end to end: gather, store, process, analyze, and visualize. Many IT biggies have also joined the big data bandwagon by either providing their own Hadoop distributions and or providing connectors to Hadoop. Some of them also have their own appliances which implement Hadoop software on top of it. Hadoop can also run on the cloud, and major players in cloud computing services such as Amazon, Windows Azure, Qbol, etc. have already made it very easy for users to run Hadoop on their virtual infrastructure. Lastly, the Apache Hadoop project has a huge community with improvements and innovations happening every day to make Hadoop better. Many companies contribute to the open source community: Hortonworks, Cloudera, Yahoo, Facebook, Microsoft, and Intel, among others. As you can see, there is a lot of action in and around Hadoop. That just means one thing: Hadoop is here to stay. So we have talked about the history of Hadoop and its standing in the current IT scenario. Let us briefly talk about the future of Hadoop as well. Well, experts in the industry believe that IT is going through a cycle of innovation once again as organizations adopt big data. And Hadoop is the technology that is enabling this. It has been a long time since IT has offered business a competitive edge, and big data is changing that. A famous author, Nicholas Carr, writes in his book on how IT was a competitive advantage in the 70s and 80s when custom applications, be it in the airline reservation systems or patient registration systems in hospitals, gave those businesses that ran them a big competitive advantage. By the end of 90s though, IT had become a commodity item with companies buying packaged enterprise systems. Because of this, IT no longer offered a competitive advantage because pretty much everyone was using the same or similar applications. As the cost of packaged software became more attractive, organizations were willing to sacrifice custom applications and the potential advantages offered in exchange for cost savings. This began the era of IT cost reduction versus IT innovation. And then along comes Hadoop and big data analytics. Businesses are once again investing in writing a plethora of custom applications that provide competitive advantages. These applications let them analyze their business in ways never before feasibly possible. Until Hadoop, processing massive volumes of data was cost prohibitive. Today, businesses are finding a variety of uses for Hadoop and big data analytics and using it for business decisions and strategy, security, and yes, more cost reductions. According to a recent study done by a CIO magazine, nearly 50% of the organizations surveyed have big data or Hadoop implemented or are in the process of implementing. The remaining organizations plan to have big data implemented in the next 24 months. Now that we are a bit more aware of Hadoop and its future, let us talk about an important aspect for every data analyst. Why should data analysts know Hadoop? Well, here are some of the reasons. For starters, as more and more organizations start adopting Hadoop, Hadoop will store a major chunk of the data generated. So it is given that a lot of analysis needs to be done on the mountains of data stored in Hadoop. Hadoop improves the productivity of data analysts. How? Hadoop, with its well-documented scaling capabilities, has the ability to store lots of data, all of it in raw format. This means that data analysts or scientists can perform various analysis by running different types of pre-processing and data preparation steps. In a well-designed architecture, you can eliminate data silos. That is, data stored in different systems can now be stored in one place, that is your Hadoop cluster. Although a data warehouse is designed for the same purpose, a data warehouse cannot handle unstructured data. Also, as learnt in the earlier videos, we will have issues in scaling a data warehouse if it starts testing the size limit. And then we all know that it's a tenet of big data analytics that the more data you have, the less complex your algorithms need to be. And finally, with Hadoop, data-driven innovation is accelerated since Hadoop is schema on read. Let us elaborate that a bit more. Hadoop allows for schema on read. That is, you need to only define the structure of data when you come to read it. This allows data to be loaded in its most raw form without needing to analyze or define the data ahead of time. You load everything at low cost and then structure the data the way you want to. As shown in the time chart here, the life cycle of an analytics project can be reduced drastically with Hadoop since with Hadoop you store raw data as compared to other systems. You do not have to wait for your IT developers to have the schema or structure changed in case you need it. And let us be honest, data analysts and scientists always need better data to work with, so schema changes are almost inevitable. In addition, another trend that we are seeing is this. Knowing the significance of Hadoop and not wanting to be left behind, many analytics companies have already integrated their tools with Hadoop. Two of the most used analytical programming languages are R and SAS, and both of them have integrated with Hadoop. R Hadoop is an open source collection of R packages that allow users to manage and analyze data with Hadoop from an R environment. It allows data scientists familiar with R to quickly utilize the enterprise-grade capabilities of the Hadoop distribution directly with the analytical capabilities of R. And SAS has integrated many of its products with Hadoop. SAS Access provides seamless and transparent access to big data stored in Hadoop. SAS helps Hadoop functionality with base SAS by enabling MapReduce programming, scripting support, and the execution of HDFS commands from within the SAS environment. As you can see, there is a lot of investment made by existing vendors to integrate with Hadoop. So whatever the level of your present understanding of Hadoop, in short, you are going to hear a lot more about Hadoop in the future. If you are a data scientist or an analyst, all the more. So knowing Hadoop and knowing it well is imperative for every data scientist or analyst. So whatever the role you will perform eventually, be it writing MapReduce programs, extracting data out of Hadoop into your system for further use, or just connecting data and running your analytics code, you should be knowing the basics of Hadoop, Hadoop distributed file system, MapReduce, Hive, HBase, Pig, and other sub-projects of Hadoop. With that, we come to the end of the videos on Introduction to Big Data and Hadoop. In this video, we covered the history and future of Hadoop. And in the next set of videos, we will do a deep dive into how Hadoop and its core components, that is HDFS and MapReduce, work. Thank you for watching and stay tuned.